A particle p is projected vertically upwards from a point A with speed u meters per second. The point A is 17.5 meters above horizontal ground. The particle p moves freely under gravity until it reaches the ground with speed 28 meters per second. Show that u is 21. At time t seconds after projection, p is 19 meters above A. Find the possible values of t. The ground is soft, and after p reaches the ground, p sinks vertically downwards into the ground before coming to rest. The mass of p is 4 kilograms, and the ground is assumed to exert a constant resistive force of magnitude 5,000 newtons on p. Find the vertical distance that p sinks into the ground before coming to rest. Let's have a look at that then. Here's the question here all summarized with all the information in the picture. We need to show that u is 21. So it's released, thrown upwards at, goes upwards at initial velocity u. It's going to reach a maximum height, falling under gravity, acceleration g, goes down and hits the ground at 28. And the ground here is from, if this were the origin then, say, then this would be a distance of minus 17.5, wouldn't it, if we're going in the upwards direction as our frame of reference. Okay, so let's have a look at that then. So here we've got the distance, we know the acceleration, we know the final velocity, and we want to find the initial velocity. So the v squared equals u squared plus 2as comes to mind here. Using this equation then, let's see what we get. So the final velocity, if we're going forwards, it's minus 28 squared, is equal to, because we're going in the upwards positive direction, u squared, and then it's minus, because g is downward, so it's minus not g here, so it's minus 2g, and the distance, if this is the forwards direction, is minus 17.5. So that tells us what u squared is then, is equal to, this will turn out to be 28 squared, won't it? Negative will go, and this will become minus 2 17.5s are 35, 35g, so that tells us then, when we square root, so let's type it in the calculator, 28 squared minus 35 times g equals square root, the answer, 21. So we just put that in the calculator and we get 21 meters per second. Now find, at time t, p is 19 meters above A. So we've got time t, and we know that s equals 19. T equals what? U is equal to 21. So that reminds us of the formula s equals ut plus half at squared, doesn't it? So let's just move this next part of the question out of the way if we can. I'll try and do that now, which is not going to be terribly easy, but I'll try. Put that down there and just move this down as well. There we go. Okay, let's have a look at this then. So this is part B. So here, S will equal ut plus half at squared. This is the formula that comes to mind, isn't it? Okay, this formula gives, so we said S was 19, U is 21, G is 9.8 minus, so this is half of that, which is minus 4.9 t squared. So that tells us then, times by 10 all the way through if we want to, but I'm going to move this over there first. 4.9 t squared minus the 21t plus the 19 that's already there. So we've moved this over to be a plus, we moved this over to be a minus, and we've left the 19 as is. There's nothing on this side, and that tells us then that 49, I'm going to times everything by 10 now all the way through, 49t squared minus 210t plus 190 equals 0. 1910s. We got 1910s. Okay. I wonder if it factorized easily. 38 fives. There's a 7 coming in here. 38 fives. It could be if I do 7 of those and 7 of those. 7 33s. No, I'm not. I'm just going to use the formula then. So here, let's use the formula then. Save me trying to factorize it. T is equal to minus b plus or minus the square root of b squared. So I can drop the minus because it's squared. Minus 4 times a, 49, times c is 190. All over 2 times 49. So that tells us the times then. T is equal to, let's type it in the calculator then. Let me just have a look at that. It was 210, wasn't it? So it's 210, 210, plus square root, so I'll do the plus one first, 210 squared, minus 4 times 49 times 190. That's the square root. So that's the top number, isn't it, with the plus. So if I put a bracket around that and go back, put a bracket around that number here, and then I need to divide it by 98, don't I? 2 times 49 is 98. So divide that now by 98 equals 2.988. 2.99, isn't it, 2dp? That's 2 decimal places. Or t is equal to, so there's the first one. And the other value, if we go back now, change that plus to a minus here. Put a minus in. 1.29, 1.30, isn't it? And that's to 2dp again. So there's the times, the possible times that are solutions for this problem. So now we need to look at the final part of the problem. How far does P sink into the ground? If we look at our original picture, there's a constant resistive force of 5,000 newtons. It hits the ground at 28 initial speed. So we've got a mass of 4. Its weight is 4g. The resistive force is constant at 5,000. So F equals ma then, in the downwards direction, gives. Okay, so let's have a look at that then. F equals ma. So what do we get? Well, downwards direction, 4g minus 5,000 is equal to mass times the acceleration. So the acceleration then, a, is equal to 4g minus 5,000. So move the 4 from times to divide. So let's just go back and check what the question wants us to find out. Part C. Find how far P sinks into the ground. Okay, so we now know the acceleration. We want to find out how far it sinks into the ground. The initial speed downwards was 28. Okay, so V squared equals U squared plus 2AS, isn't it? Gives, when it stopped sinking, the V will be 0. The initial speed was 28. And the acceleration is this. So it's plus 2 lots of this. So this will be 4g minus 5,000 over 2, because I've doubled it, because there's a 2 there. So 2 will cancel to leave 2, times the distance s. So s will equal then, the distance in the ground is equal to minus 28 squared divided by this number, 4g minus 5,000 over 2, g equals minus 28 squared. Divide by the 2, you get 2g minus 2500. Then we can flip a minus on top and bottom, can't we? So it's 28 squared over 2500 minus 2g. So I've flipped a minus here, and I've run a minus through this bracket and written it the other way around. So s is equal to 28 squared then, divided by bracket 2500 minus 2 times 9.8, close bracket, equals decimal 0.32 meters. 0.32 meters. And that's the 2 decimal places.